students, welcome to Shruti Academy. So let us start with the theorem number 6.2 of chapter 6, triangles for class 10 CBSE NCERT. So the theorem 6.1 was the basic proportionality theorem or the Thales theorem, and the theorem 6.2 is the converse of basic proportionality theorem. Okay, so let us see first the statement, and later on we will be proving this theorem in this session. Okay, so the statement says if a line divides any two sides of the triangle in the same ratio, then the line is parallel to the third side. It is the converse of the theorem 6.1, which was the basic proportionality theorem. Okay, so here it is saying that the line divides any two sides of the triangle. That means DE is dividing two sides of the triangle, then in the same ratio, that means it is given to us that AD upon DB is equal to AE upon EC. Then when the ratio is same, then DE is surely parallel to BC. So we need to prove that DE is parallel to BC. So given over here, we are given over here that the ABC is a triangle and the line DE is intersecting. Line DE is intersecting the sides AB and AC at D and E respectively. Okay, at D and E respectively, such that also we are given that they are in this dividing, the line is dividing in the same ratio such that AD upon DB is equal to AE upon EC. So we need to prove over here that DE is parallel to BC. DE is parallel to BC. Basically, the whole theorem emphasizes this only, that DE is parallel to BC if they are given and that they are in the same ratio. So for that we need to do one construction. We need to draw DE dash. You can take any point over here. I have taken E dash over here. You can denote it with any point, anything or as such. So E is over here, E dash over here. So I am drawing DE parallel to BC. I am drawing this construction, DE dash parallel to BC. Okay, so when my DE dash will be parallel to BC, with the theorem 6.1 we can easily state, if I have drawn side parallel to the one side of a triangle such that it is intersecting the other two sides, then surely it is in the same ratio. So easily I can say that AD upon DB is equal to AE dash upon E dash C is equal to AE dash upon E dash C. So this means that the AE dash, DE dash I have taken to be parallel. So let us write the reason over here from theorem 6.1, which is my BPT, basic proportionality theorem. So AD upon DB is equal to AE dash upon E dash C. So let us mark this to be equation number 1. Let us mark this to be equation number 1. Now we have been given to us that AD upon DB to be equal to AE upon EC. This we have been already given. So let us mark it as equation number 2. Let us mark it as equation number 2. So from 1 and 2 we can clearly see that our LHS is equal in both the sides. LHS is equal in both the sides. So from equation 1 and 2 we can clearly say that AD upon DB is equal to AE dash upon E dash C is equal to AE upon EC. Okay, so we got this result. Now what we will be taking these two. We will be taking these two. So let us take these two. So AE dash When the LHS is same, the RHS will also be equal. Okay, so AE dash upon E dash C will be equal to AE upon EC. AE upon EC. So now the next step is adding 1 to both sides. Adding 1 to both sides in equation number 3. So let us mark it to be equation number 3. Okay. So let us add 1 to both sides. So AE dash upon E dash C plus 1 should be equal to AE upon EC plus 1. Okay. So taking the LCM over here. So E dash C will be the LCM. So here we will be getting AE dash plus E dash C. Similarly, over here in the RHS also we will be taking the LCM. So we will be getting AE plus EC. Okay. So now let us see AE dash and EC dash. So AE dash plus EC dash gives us here to be AC. So it will be AC upon E dash C. So that means, and over here also AE plus EC. AE plus EC will also be equal to AC. From the figure it is very much clear over here. So AC upon EC. So this gets cancelled. AC gets cancelled both the sides. So from here we will be getting 1 upon E dash C to be equal to 1 upon EC. So again the C gets cancelled. Cross multiplication we are doing. So we are getting over here E dash is equal to E. E dash is equal to E. So let us mark it to be equation number 4. Okay. So let us mark it to be equation number 4. So when E dash is equal to C, what does this mean? This means that the points are coinciding. That means this is nothing but E dash and E are on the same point and at the same place. So from 4, it's clear that E dash and E coincides. That is, both are same point. Both are at same place. Both are at same place. So they are at the same place. That means E dash and E both are coinciding over here itself. So we can easily say that it is given to us that AE upon EC is equal to AD upon DB, and we have already assumed to be DE dash parallel to BC. So we can easily say that DE dash is parallel to BC. Similarly, DE will be also parallel to BC. So here DE dash is parallel to BC, assumed previously. Okay, so when DE dash is parallel to BC, so from 4 we can easily say that DE is also parallel to BC. So DE is also parallel to BC. From 4 it is clear because both are coinciding and both are at the same place. The point is at the same place. Both are coinciding. Okay. So we have already assumed to be DE dash parallel to BC. So when we are saying DE dash is parallel to BC, so from 4 we can also say that DE is parallel to BC. And this thing only we need to prove over here. Hence proved. Because we need to prove that the line which is dividing the two sides of the triangle in the same ratio is parallel to the third side. So the third side is BC and the line is DE. We have assumed previously that DE dash is parallel to BC, and now since we got a conclusion that E dash and E coincide at the same point, at the same place, so DE is parallel to BC. Okay, so in this manner we need to prove this theorem. So stay tuned, we will be proving more of the theorems of this chapter. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.